The diagram shows squares placed inside two identical semicircles. In the lower diagram, the two squares are identical. What is the ratio of the areas of the two shaded regions? So now these are the squares. So squares meaning they have all equal sides. So therefore we can say that if they are sides A. Now there's one thing that's happening here is because they're semicircles and this is symmetrical, the shape with the square. So if the line of symmetry would pass through the center of the circle. So if we say this was O, the center of the circle, then yeah, that's A. So this would be A out of 2. It would be A out of 2. Okay, and if we try and do similar things for the next shape, so if we put this as O, this is already the line of symmetry there, and that's the center of the circle. And so we can say that the sides are B, two squares, so B and B, and also B, B, and B. Of course, that line is B. So this is what we assume. Now we have to find something common between A and B to get to the ratio. So the common thing we're going to find is the radius, and the radius is R. So if you join from the center to the circumference, you will get R, and the radius is the same in both the drawings because they are two identical semicircles, so they will both have the same radius. So once we know that, we can work out for this shape, for this particular shape, we can work out a relationship between R and A and R and B. So the area of the square is area equals, so this we call it as A and we call this as B. So if we say the area of A would equal A square, because the sides are A square, and also bring in R, to bring a relation between R and A and B, we can say that R square, applying Pythagoras' theorem. So by Pythagoras theorem, so we can say that R square equals A square plus A out of 2 whole square. So if we have this as 1, and the next shape, from the next shape we get the area of B equals B square plus B square. That is twice of B square, because the area of one square is B square, the area of the other square is also B square. The total area of B, or the shaded part A here, not whole A, if I say shaded part, or it would mean the wrong thing. Here is also the shaded part B. So the A is the shaded part, A and B. So the shaded part B is twice of B square. Now if we try to link R and B, we see that R square equals B square plus B square. So we get R square is twice of B square, and that would be 2. So if we have to form a relation now, r square, so instead of r square here, we can put in twice of b square, and we will get twice of b square equals a square plus a square out of 4, and that equals 5a square out of 4. Or we can say b square is 5a square out of 8. That's what we get as b square. So the ratio of the areas, or do we have to do that? No, we don't have to do this part. Right, we don't have to do this part because yeah, we just have to do this. That is 4a, 5a square out of 4. Just have to leave it like this. The reason is, so because this is the area of the part B. So if we say area of shaded way, area A shaded to area B shaded, and that would equal the area of A is A square to B to the area of the part B is twice of B square. So that would give us A square is to 5a square out of 4. So from here, that is twice of b square, so this we can simplify and we get 4 is to 5. So the ratio of the areas of the two shaded regions is 4 is to 5.